Six Sigma, Operational Definitions and Baseline Performance. Today we are going to focus on two foundational concepts in Lean Six Sigma: operational definitions and baseline performance. These may sound simple, but they are extremely important. Before a black belt team can analyze a problem, identify root causes, or prove improvement, the team must first be clear about what is being measured and what the process is doing today. Operational definitions help us make sure everyone is measuring the same thing in the same way. Baseline performance helps us understand where the process is starting from before we make changes. Together, these concepts help prevent one of the most common mistakes in improvement projects: making decisions based on unclear, inconsistent, or incomplete data. As we go through this section, think about a process in your own work area where people may use the same word but mean different things. That is often where operational definitions become very valuable. Operational definitions. An operational definition is a clear and specific explanation of exactly what will be measured and how it will be measured. In Lean Six Sigma, we do not want vague measures. We want definitions that are specific enough that two different people could collect the same data and reach the same conclusion. For example, the slide uses the example of late deliveries. At first, that sounds simple. We might say, we want to reduce late deliveries. But before collecting data, we need to define what late actually means. Does late mean the product was delivered after the customer promised date? Does it mean it shipped after the internal scheduled ship date? Does it mean it arrived after the carrier pickup window? Or does it mean it was more than 24 hours late? Each of those definitions could produce a different defect rate. One team might report a 3% late delivery rate, while another team, using a different definition, might report 12%. Both teams may believe they are correct, but they are not measuring the same thing. That is why operational definitions matter. They remove ambiguity. A strong operational definition usually answers several questions. What exactly are we measuring? Where will the data come from? Who will collect the data? When will the data be collected? What counts as a defect, error, success, or failure? What is included and what is excluded? In a black belt project, this is especially important because later statistical analysis depends on the quality of the data. If the data collection method is inconsistent, then the analysis can be misleading, even if the statistical tools are used correctly. The simple takeaway is this: an operational definition makes the measurement repeatable, consistent, and credible. Baseline performance. Now let's move to baseline performance. Baseline performance describes how the process is performing before any improvements are made. It is the current state of the process. This is important because Lean Six Sigma projects are expected to demonstrate measurable improvement. To do that, we need to know where we started. For example, if a project team says, "We improved the process," leadership should ask, "Compared to what?" That is what the baseline provides. Baseline performance helps answer several key questions. How bad is the problem today? How often does it occur? What is the current defect rate, yield, cycle time, cost, or productivity level? How much improvement is realistic? And after the project, did the improvement actually happen? Without a baseline, the project team may rely on opinions or anecdotes. Someone may say, "The process feels better," or "We seem to have fewer issues." But Lean Six Sigma requires evidence. Baseline data gives the team a factual starting point. A good baseline also helps with project scoping. If the problem is very small, it may not justify a black belt project. If the problem is large and costly, it may become a strong candidate for improvement. The baseline also helps establish the project goal. For example, if the current defect rate is 6.8%, the team may set a goal to reduce it to 3% or lower. But without the current defect rate, that goal would be arbitrary. The simple takeaway is this: baseline performance tells us where the process is starting from so we can prove whether improvement occurred. Baseline performance example. This slide gives us a simple manufacturing example. The team wants to reduce defects on a production line. Before making changes, they collect baseline data. The current defect rate is 6.8%. First pass yield is 93.2%. Average rework cost is $18,000 per month. And the process affects about 1,250 units per month. These numbers are important because they define the size of the problem. A 6.8% defect rate tells us that nearly 7 out of every 100 units are not passing as expected. A first-pass yield of 93.2% tells us that a meaningful portion of product requires rework, repair, review, or disposition before it can move forward. The $18,000 per month in rework cost translates the quality problem into financial language. That matters because leadership often needs to understand not only the technical issue, but also the business impact. The 1,250 affected units per month helps the team understand the scale of the issue. This is not a one-time problem. It is recurring and measurable. Once this baseline is established, the team can compare future performance against it. If the defect rate drops from 6.8% to 2.5% and rework cost drops from $18,000 to $7,000 per month, the team can show a measurable improvement. This also helps prevent false conclusions. For example, if defects drop for 1 week, that may be normal variation. But if performance improves and remains better over time, compared to the baseline, the team has stronger evidence that the project made a real impact. The key point is that baseline data creates the reference point for the entire project. Baseline performance results. Baseline performance results are the documented current state results of the process before improvement. This is slightly different from simply saying, here is our baseline. Baseline results should be specific, measured, and tied to the project goal. For example, if the project is focused on defects, baseline results may include defect rate, first pass yield, scrap cost, rework hours, and customer complaints. If the project is focused on cycle time, baseline results may include average cycle time, median cycle time, range, queue time, and percent completed within target. If the project is focused on investigations or documentation, baseline results may include average closure time, backlog size, error rate, number of review cycles, or percent completed right the first time. The slide also points out that baseline results help us understand variation. This is important because two processes may have the same average but very different levels of variation. For example, one process may average 10 days to complete, with most items finishing between 9 and 11 days. Another process may also average 10 days, but some items finish in 2 days and others take 30 days. The averages are the same, but the second process is much less predictable. That is why black belts should look beyond the average. They should also consider variation, trends, stability, and whether the process is predictable. Baseline results help answer, how often is the problem occurring? How much variation exists? What is the current cost, yield, cycle time, or defect rate? Is the process stable or unpredictable? How will we prove improvement after changes are made? This is a major part of disciplined improvement. If we cannot describe the current state with data, it becomes very difficult to prove that the future state is better. Baseline performance results example. This slide shows a more complete baseline performance example for a packaging defect project. Before making improvements, the team collects 3 months of data. The baseline shows monthly production volume is 50,000 units. Packaging defect rate is 4.8%. First pass yield is 95.2%. Monthly rework cost is $22,000. Average investigation cycle time is 18 days. These metrics give the team a clear picture of the current state. The defect rate tells us the frequency of the quality issue. First pass yield tells us how much product moves through the process correctly the first time. Rework cost shows the financial impact. Investigation cycle time shows the effect on quality system workload and responsiveness. After the project, the team compares the new results against the baseline. The packaging defect rate drops from 4.8% to 1.6%. First pass yield improves from 95.2% to 98.4%. Monthly rework cost drops from $22,000 to $7,500. Investigation cycle time improves from 18 days to 9 days. This before and after comparison is powerful because it shows improvement across multiple dimensions. The project did not only reduce defects. It also improved yield, reduced cost, and shortened investigation time. Let's look at the cost impact. Rework cost dropped from $22,000 per month to $7,500 per month. That is a reduction of $14,500 per month. Annualized, that would represent approximately $174,000 per year in reduced rework cost, assuming the improvement is sustained. That is why baseline performance is so important. It allows the team to quantify the benefit in a way that is meaningful to both technical teams and leadership. However, a black belt should also be careful. Before claiming success, the team should confirm that the data was collected using the same operational definitions, the same measurement method, and a comparable time period. Otherwise, the before and after comparison may not be valid. The simple takeaway is this: baseline performance results provide the evidence needed to show that improvement occurred and that the improvement matters. To close this section, operational definitions and baseline performance work together. An operational definition makes sure the team is measuring the right thing in a consistent way. Baseline performance shows how the process is performing before improvements are made. Without operational definitions, the baseline may not be reliable. Without a baseline, the team cannot prove improvement. For a black belt candidate, these are not just documentation exercises. They are the foundation for good analysis, good decision-making, and credible project results. When starting a project, always ask, do we know exactly what we are measuring? Is everyone using the same definition? Do we understand current performance? Do we have enough baseline data to compare before and after results? Can we prove that the project made a measurable difference? If the answer is yes, the project team is much better prepared to move into analysis, improvement, and control.